As you can probably tell from my accent, I'm not from these locales. We're actually based in Sydney, Australia, listed on AIM, and I've been promised I'm going to get a question about that at some stage. So let me start with who we are and what we do. We develop energy storage technologies and their solutions, and they're based around our supercapacitor technology. So we started off just making supercapacitor cells, and we've morphed over time to adding more value add in that. And by value add, I mean now integrating electronics into that, packaging that, and rather than taking a brief from, say, an automotive company, which says, can you give us so many cells of 6,000 farads and an ESR of 0.1 milliohms, they now say, we have this problem. The problem is that we want to get a certain range out of our batteries in our hybrid car. We have a certain voltage that we want to run the system at, and we have these peak currents. And when we draw these peak currents out, you know what? The battery voltage collapses, our electronics turn off, and the customer's not very happy. So how are you going to solve that, or can you solve that for us, CAP-XX? And I'm going to tell you about that shortly. And so lately we've been getting inquiries from automotive OEMs and some tier ones who give us that sort of problem, and then we engineer the solution and go back to them with essentially a black box that includes our supercapacitor technology and our electronics. And if there's one thing I'd like you to take away from tonight, it's that the things that CAP-XX does well, it's around the material science, which is fundamental to making a supercapacitor, and I will explain what a supercapacitor is shortly, and the electronics that go with it to really extract all that value out of that material science know-how. We've been going since 1996 as a startup, and certainly in a garage effectively. We are the market leader in high power supercapacitors. So there are other supercapacitor companies out there, but we have exceptionally high power. And also what sets us apart is that ours are very thin and in a prismatic form factor. Now, nearly all of our competition today are making supercapacitors in cans. Now that may not sound like a big deal, but when you come to package them into something like wearable tech, where you want to have it in a piece of clothing, or you want to have it in a credit card, or you want to integrate it with lithium-ion batteries, which are also prismatic, it's a huge advantage. No one's going to put a can inside a credit card. They can put our 600 micron thin supercapacitor inside a credit card. Okay. So that's one thing. A lot of IP, and I'll talk more about the IP, but as a proof that we have strong IP, two of the very biggest electronic passive component, active component manufacturers in the world, Murata in Japan and AVX out of America, have both bought licenses from us. And they only did that because our IP has real value, both in terms of know-how and also in terms of patent protection. And our licenses give those two big companies the freedom to operate. We are targeting, out of all of the markets for supercapacitors, and there are, believe me, an awful lot, and we could spend several nights just going through all the different market segments, we're focused on just a few because we are a very small company. We are 25 people, and we outsource a lot. Out of that 25 people, by the way, more than half have PhDs, master's degrees of science or engineering, and are predominantly focused on that R&D and that engineering aspect of the business. And we're spending 3.6 million, these are Australian dollars, 3.6 million Australian dollars every year on R&D. That's an awful lot for a company that, in the results that came out on Monday, generated only 4.1 million in revenue, but I'll talk to that point as well. We have sold, over that history though, of several years, 24 million cells. So we have absolutely learned how to manufacture supercapacitor cells and how to do the integration and packaging of those. We're headquartered in Sydney, as you can probably tell from my accent. We do most of our R&D there. We collaborate also R&D globally with other organisations, both research organisations and major companies. And we came onto the AIM market in 2006. I could go through the sordid history of how that happened and why it happened, and maybe if you like in Q&A we can cover it, but I won't dwell on that now. So, map of the world, as you can see, we're in Sydney. We make, in terms of the manufacture of the supercapacitor, a lot of the IP is in the electrode. And so in the supercapacitor, it's the electrodes that come together, separated by, in our case, separator, that hold the charge. And we do that process in Sydney because that's where a lot of the IP is, frankly. For the small supercapacitors, we then send that to our contract manufacturer in Malaysia, who completes the assembly operation, testing, marking, etc., packaging, and then at our direction ships that to our customers. And our two licensees, Murata and AVX, as you can see, one in Japan, one in the US, and we assisted in our sales force because with 25 people, we don't have a big sales force. We have to rely both on AVX, Murata, but also our manufacturing reps and distributors, agents around the world. Okay, what is a supercapacitor? So a supercapacitor stores electrical energy, just like a battery. Only a supercapacitor does it through charge separation. We're not talking here about chemical reactions. So if you think about lithium-ion batteries or lead-acid batteries, when you charge them, you're driving chemical reactions in one direction. If you're charging where you're putting electrons in and they're transforming into new chemical compounds. And when they discharge, those chemical reactions reverse, hopefully, and you get the electrons out. That's chemistry. Supercapacitors rely on charge separation. So it's a bit like static electricity. And that makes it very fast. We're relying on physics here. Physics is much faster than chemistry. And so when we start talking about the usefulness of supercapacitors, we're talking about how much power they have, as much as we talk about how much energy they can store. Now, everyone here in the room would know that you can't store power. I mean, that's a given. You can store energy, but you can't store power. And what we give to our customers, the enabling feature, is very, very high power. That is, the ability to get that energy out instantaneously, not waiting for it to dribble out like a battery. And if I use the analogy on the chart here, so I think it's a good one to explain the difference between energy and power. Think of the amount of energy you can store as how much water you can put into a storage container. So I can have a battery represented by an Olympic-sized swimming pool, lots and lots of water. And a traditional capacitor, and I'm going to use a pointer here for a moment, like this one over here, a little electrolytic capacitor, may only be the equivalent of a cup of water. That's how much energy. The supercapacitor fits in between. We're sort of like a whirlpool or a spa bath of water. But power, think of the power of these devices related more to the size of the tap attached to those tanks. And in the case of the little traditional capacitor, it's got a great big tap on it. But in the case of the battery, it's a tiny little tap. It's like a garden tap, and you're trying to get all this water in and all the water out. In, out. And it takes a long, long, long time to charge. And I think you've all seen that as people talk about electric vehicles, the time to recharge is an example here. The supercapacitor is like having a huge fire hydrant and several of them in there. We can get all that energy in like that and all out straight away. Right? And that's power. That's what we sell. We're selling power, the ability to do things instantaneously. And that's really valuable. Very quickly, what's inside? The supercapacitor is made up of the two electrodes I mentioned with a carbon coating on it. This is like the secret herbs and spices. That's our core IP. It's made up with a separator in between, which allows the electrons, or the anions and the cations, to flow between them. It's packaged, and it's got this electrolyte in there. Very simple. Our real benefits, as I mentioned before, is our understanding of the material science, the nanotech aspect of it, the ability to tailor the carbons and the coating to maximise the power we store. And of course the smart electronics and the IP that goes with it. So the results that we put out on Monday, we had a total sales revenue of only $4 million Australian. That was down 17% on the previous year, and as we had announced to the market back in February, this was due to a problem we've had with one of our raw material suppliers. Now, the raw materials we buy, in general, don't have a lot of engineering or value add to them. But some of these raw materials are all slightly different from one supplier to the next, and you can't use one interchangeably without going and tweaking the formula. In our case, this supplier made a change to their process without alerting us, and the result was that when it got into our production, we noticed there was something wrong. This product wasn't coming out the way it should. It wasn't meeting our specifications. Fortunately, we were able to stop production before it got to the customer, but it took us several weeks to then go and flush out what the problem is, get the supplier to admit what had happened, and go back. And that effectively cost us over $700,000 there. But the thing that I'd like to draw your attention to is the growth in the royalty and the licensing income. So our business model is founded on two arms. There's an arm which is all around licensing IP, and we do that by getting an upfront fee plus a running royalty on sales, and on making product and selling product. And what we're seeing now, and I'll show you some slides that demonstrate that, is we're seeing an acceleration in the royalty income we're getting. So this is like an annuity stream coming in from our licensees, together with the upfront fees we get there. We also receive these upfront fees we get, and AVX being the last licensee we signed up, we receive in these results the second of 3 upfront license fees. And again, so there's almost half the revenue here is made up of the royalty and license fees coming through. We did make some operational OPEX cash savings during the year, about $500,000, but not by touching any of the R&D spend, the engineering spend, or the sales spend. It was really coming out of peripheral parts of the business. Things that are essential, but you don't really want to spend money on. I'm talking about telephones, insurance, rent, share-based payments, and other things there. Now, and the result was that our average cash burn during the year was running at about 79,000 Australian dollars a month. To put that into context, we closed the year on 30 June with 3.9 million in cash. And one of the things that's probably unique to Australia is that based on how much you spend each year on R&D, you get about 43.5% back in cash from the government. Not as a future credit on tax, but you actually get a cheque, hard cash. And our R&D spend, our total overhead's about 5.3, our total R&D, eligible R&D is 3.6. So we spend a lot of money on R&D. And as a result of spending 3.6 on R&D, we get a cheque for about 1.55 million. That cheque comes in the next couple of weeks. So we're okay for cash. I don't have the begging bowl out at the moment. In terms of recent operational wins, we did announce in August our very largest order to date for a thin-line supercapacitor. These are the ones that are for 0.6 of a millimetre thick. And this was for Wearable Technology. The value of the order is over 524,000 Australian dollars, a bit over 400,000 US dollars. And this is then based on the customer's expectations. We should be receiving significant follow-on orders to come from this. We also see increasing interest and opportunities coming through from other wearable technologies and energy harvesting applications. You may have heard of this title, the Internet of Things. Well, a lot of what we do fits under this umbrella of the Internet of Things, but I want to be more specific than just use that term. I want to tell you about individual market segments. Our 2 licensees also performed very strongly during the year. Murata royalty to us is up, and at the same time they launched a number of new products. AVX also launched a number of new products in different areas, and that's giving us traction or giving us entree into new markets where previously we didn't have exposure. We also developed a number of new products for the automotive industry that I mentioned before, and I will talk about those in a little while. And we developed a lot of new IP, new products that's coming through, and that will follow through into new patents as well. So in terms of the licensing, I've already mentioned Murata, and that's they're going well. We certainly expect their royalties to keep growing. AVX, who bought a license a little over a year ago, still has some catching up to do, but I've got to say the board is exceptionally pleased with the progress that AVX has been making, the commitment they've made to getting new products out there. And what I can say, and what we've said before to the market, is that we are looking to sign additional license agreements. You'll appreciate that signing a license agreement isn't something that CAP-XX can control by ourselves. There's at least one other party involved, and so we can't be too definitive about the timing of that. But we remain optimistic that we'll have news on that shortly. A little bit about Murata and AVX. Both of them are very large companies. I mentioned they're some of the largest in the world when it comes to making small electronic components. Both have a market cap of over $3 billion US dollars and sales in the billions of dollars. Both licenses are non-exclusive, and both licenses limit the licensee only to make and use our technology in certain areas. And you might ask, well, why do we do that? Why not let them do everything? And the answer is that because the first thing a licensee does is when they come to you and they say, you know, what can I have, is they want exclusivity and they want to be able to do everything. But when you boil down to it and you say, well, if we're going to give you exclusivity and we're going to let you do every application there is, some of which we may not have even thought of yet or even been invented, how are we going to make sure that we're getting good value out of that? You're going to have to pay us a lot of money to do that. And that's when, you know, the sort of conversation gets a lot more realistic, and we sort of focus very quickly on what business are they in. Are they in the market for small supercapacitors and looking at energy harvesting, or are they really interested in getting into large industrial applications? And so therefore we focus those discussions down as much as possible to where there's value for both sides. I mentioned Murata. This is a chart showing how the Murata royalties have increased over time. There are no dollar numbers on here, and I won't give you the dollar numbers if you ask me, out of respect to Murata and keeping this information confidential. But what I can demonstrate to you is the growth of those royalty numbers over the last couple of years. And on the right-hand side is one of Murata's new products, only 0.4 of a millimetre thick. So it's a lovely looking product, and I do congratulate Murata on getting that out into the marketplace. The other thing is that Murata, at Murata's request, has extended, or we have extended, the license terms that we have with Murata to now include small lithium-ion batteries. So they are using some of our patents to make little small lithium-ion batteries up to 50 milliamp hours. And we think that this is, again, for the sort of markets that Murata's targeting, should be a very attractive market. AVX, on the other hand, is looking to enter more industrial, larger scale markets. So they've introduced some modules lately, 48 volts and 16 volts, that are really aimed at things like the grid, energy storage at the grid level. It's around wind farms and pitch control for turbines. It's around UPS systems. It's about diesel generators and how do you start them. So much bigger units. And this is great, as I mentioned, because it's an entree for us going into new markets we weren't previously in. So that's a little bit of our licensees. I now want to talk about where we're focusing our own sales effort. Before I do, though, I mentioned before the strategy is very much around licensing and getting value out of our IP, but also about making our own sales. A lot of the markets that we go into and actually sell to, we are doing with the strategy that ultimately we will license or joint venture with a much bigger company who will then go and really expand that market opportunity. So for instance, we really have no intention, or we don't ideally want to ever be making product for the automotive markets, even though we're developing automotive products. Because we would expect that as we're successful there, we will pull together JVs or license deals, and someone will take that over. And we are in discussions around exactly that. So I'm going to talk now about small supercapacitors, and then I'm going to talk about large supercapacitors. On the small supercapacitors, the markets that we are currently most focused on is around wearable technology. And wearable technology for us is anything that the individual might wear, whether it be on the wrist, sewn into a piece of clothing, or stuck onto the skin. It might be a medical device, and so there's a picture up there of a little insulin pump where you have a button cell battery, a CAP-XX supercapacitor, and it's pumping insulin into the type 1 diabetes patient as they need it. Right? So that's a wearable device for us. We have articles of clothing where we have sensors built into them, and we supply the supercapacitor that goes into the sensor to monitor whether wellness functions or fitness athletic functions. And we certainly see all of that as a very expanding, growing market segment for us. The other one is energy harvesting around industrial, commercial applications. Here we're talking about smart building controls and industrial control monitoring systems, whether they be monitoring tanks. The picture on the bottom left is a pump made by ABB, C. Brown Boveri. It has, as you can see, a solar cell or PV panel on it and a supercapacitor inside that. And the supercapacitor is then taking the energy out of the solar cell and is running the solenoids and the communication back to the control system on that valve, for instance. And again, we're seeing a high level of inquiries there, and we're certainly expecting that market to grow as well. Third, RFID. And so we've been in RFID for many years, things like location tracking. If someone wants to know where their truck is, where their railway carriage is, where their grandmother is, or where the dogs are, or wild animals, we're in all those markets, supplying supercapacitors linked to typically GSM, GPRS type radios. And also, this is now becoming smaller and smaller, and so now you're seeing the supercapacitors needing to be embedded into things like security cards and credit cards for both biometric security access, but also financial transactions. And lastly, metering, smart metering. Here, the supercapacitor is often used to provide backup power in case there's failure, so that the meter reading can be transmitted back to the utility company when there's a power outage and they know where to pick up the bill when power is resumed. So that's the small supercapacitors. The large supercapacitors, as I mentioned, we came late to this market, so in the last couple of years we've been developing firstly the cell, and now the capability to package the cell and put it together into a system with know-how. And we're really focused on just a couple of opportunities. The first product we brought to market is Truckstart, and this is a 12-volt system. So it's intended for the North American market rather than the European market here, which with control electronics, where it's intended to replace one of the batteries in either a delivery van or a semi-trailer, and it provides all the cranking power when you want to come and start it. So it's relieving the batteries there of the need for those high bursts of power and extends battery life. The next two products are products we've made for OEMs, the car OEMs, and these are for passenger vehicles, and in particular hybrid vehicles. Both are 12-volt systems. One of them is providing the stop-start together with regenerative braking. So that's when you put your foot on the brake, where does that energy go? And it goes into the supercapacitor. And when you put your foot on the accelerator, that energy that was in the supercapacitor can now go back to the driving wheel. So it's giving a burst of power as well on the output side, much more efficiently than you could ever do with a battery system. The third one does something similar, but it's providing a lot of support to all the electronics inside the vehicle. So here we're providing a smoothing or buffering feature for the rest of the vehicle. And the last one is a 48-volt battery pack, a supercapacitor battery pack to work again with hybrid vehicles. One of the other things we did during the year is we launched a range of small supercapacitors in can format. The reason for that is really to extend the sales reach that we get for our smaller supercapacitors in the prismatic form factor, because there are a number of can supercapacitors out there. They are selling at a lower price point, and we were missing opportunities where a customer might go to our manufacturing rep or our sales team and say, well, we really don't care about size and we really want something cheap and cheerful and it doesn't have to last 10 years. What have you got? And our price is too high, and they'd go off and buy a can from someone else at a fraction of the price and would lose that opportunity. We don't want to do that. We'd rather own the customer. So if they want a cheap can, we can give them that and then hopefully sell them up to a prismatic at higher power, more volumetrically efficient, a higher performance part. But if the can's better, then at least we can keep that and work with that customer over this product design and the next design cycle as well. And throughout the year we made, as I mentioned, a lot of improvements in terms of R&D, both for existing product, but also in terms of improving our fundamental technology for the supercapacitor. We've got a number of new product ideas that are very much focused on what our existing customers are asking for and how we might extend that. And of course, as we do this, we're generating more IP, more patents, and that allows us to extend the reach that we have in our patenting and licensing model. So with that, let me say thank you very much for being such a good audience, and I'm happy to take any questions.
Thank you for a very interesting presentation. My question is, what is your market cap now, and what's the share price now and also a year ago? And what is your vision in 5 years' time? What do you expect, your gut feelings about your market cap or your value of your shares?
I've got one of our brokers in the room here, and I don't think I'm allowed to answer the last part of the question. I can give you the historical. But I'm happy to point you to Graham Bell over here from Allenby, and he can give you all the financial advice you need. So the first part of the question is market cap. I think our market cap is currently at about 40 million pounds, something like that, 43, something like that. Current share price is, I think, 13.5, 14.5p. A year ago, I think it was about 4p, something like that. We really want to build out that whole licensing royalty part of the business and keep building that annuity. And we look to companies like ARM Holdings as just a great model of how do you extract IP out and keep leveraging that up. And so more and more as we look to new markets, we're trying to avoid being sucked into putting a lot of our own investing capital equipment into those markets, but would rather partner with others, and particularly big companies. So we're trying to see more and more partnerships come through, more and more licenses, more and more royalty income, and we'd love to see ourselves being really, having a strong foothold in some of those markets I just talked about at very much larger volumes, 10, 100 times larger than where we are now.
So who do you think your competitor?
Oh, I know who our competitors are. So for small supercapacitors, our biggest competitor is Murata, our licensee. We compete with them quite often. Particularly in some markets like smart metering, etc., and solid-state drives, a market I didn't talk about, but we're in solid-state drives. In the large supercapacitor market, the biggest players are companies like Maxwell Technologies out of the US is one. You've got Nippon Chemicon in Japan. Nescap was acquired by Maxwell Technologies, so they're no longer there, and Panasonic. And Maxwell's much bigger than us. However, when you line up the allies on both sides of the table, having AVX and Murata behind us and pushing out technology and with the revenue stream we're getting from those, we're actually got a pretty good bunch of partners there to work with. I hope that answers your question.
You said earlier that you don't currently have the begging bowl out. Can you tell us when you last had it out and for how much? And also, your current market cap is, as you said, about 45 million. Your sales are 4 million Aussie dollars, and you're losing money. When are your brokers forecasting that you're going to get to EBITDA break even?
So I'll take the last question first. So I think the last research report from Allenby, which came out yesterday, has us break even in not this financial year, the next financial year. What was the first question? The last raise. Well, actually, it was a case where one of our institutional shareholders came to us at the beginning of this calendar year and offered us money, and we took it. And that was done at 9p.
And how much did you raise?
Oh, I think about £2 million.
You mentioned Maxwell just now, and that has been a sort of well-examined supercapacity company for a number of years. There's always seems to be a jam tomorrow thing about this supercapacity, and Maxwell suffered from that. Is there really some jam tomorrow? Is there a big enough market for this thing to really start expanding?
Yeah.
Enough sales?
I think so. If you look at even some of the smaller automotive programs, and I can only go by the RFQs we've received from the car OEMs, they are well up there in hundreds of millions of dollars for the supercapacitor component.
But it has always been that way for the last several years.
I would take exception with that on the point that you mentioned Maxwell. I think Maxwell's running at about 120 million in sales, and it was larger. And I don't want to comment on a competitor's misfortunes, but they were selling a lot into China, and the Chinese, my understanding is the Chinese government changed policy, which meant that they were out of favour, and but they certainly have been making big sales there.
Just to understand the competitive positioning of the technology, if we take your Truckstart application, how does the cost for the end user of one of your supercapacitor battery replacements compare with a conventional lead-acid battery?
So the payback, it's around 6 to 9 months. Now we're looking to sell this at around $500 to $600 US. Maxwell have a version of this, and they're selling it for, I think last time I looked it was about in the 800s or 900s. We would claim we have a superior product, and we believe that based on some independent testing that's been done. But it's a very short payback period. But the truck industry is also a very conservative industry, and you've got multiple parts of that value chain you need to sell to. So you're selling not only to the OEM, who's building the truck, but the fleet operator. And in fact, you need to get to the fleet operator because they're the ones who are going to get the benefit of that payback period. The payback period is made up, the parts of that is not just any savings on fuel, but it really comes about because of the amount of uptime with the truck. There's a very high percentage of trucks at any time that are off the road because of flat batteries or other issues. Here you can guarantee that uptime, and so that's really if you just look at the cost of a call out for getting a truck with a flat battery back up and running, whether it's in the yard or out in the middle of the highway, is exorbitant.
So the selling point is really the reliability of the device.
Yes,
the fact that, as you say, you'll have fewer outages for the truck, rather than simply the comparative cost against that of a lead-acid battery, which would be a lot cheaper than the sort of price you're quoting.
Yes.
Yeah. Thank you.
That's absolutely right. It's really not that replacement. It's around guaranteeing that your truck is going to be running and on the road. And I should make the comment, not one that I made before. Supercapacitors work much better as the temperature drops than any battery will, again because of this distinction between physics and chemistry. So we can work very happily down at minus 40 Celsius. There aren't too many battery technologies that enjoy those conditions.
Anthony, perhaps could you tell us something about the lead time for some of these deals, especially around the wearables? I imagine they take quite a long time to do. And here I'm really referring back to the fact that in early June you warned that some of these might not land before the end of the financial year, which was the end of June. And we're now 4 months on. We've had one deal announced, but nothing else. So is there quite a long lead time?
Some of the lead time, are you talking about licensing here or design wins for, say, wearable technologies?
Design wins, yeah.
That can vary. So I can give you an example, a live one at the moment. A couple of years ago, we were working with a big company on a wearable type application. And they'd done some testing and we'd given them some budgetary costing, etc. And the answer came back, look, this just doesn't fly. We don't think we can sell it at a price where it's going to be attractive to the market, and we've dropped the project. 2 years go by and we've completely forgotten about this. The customers now come back and said, actually, we now think it works because there's been some new power ICs on the market that take some costs out of it. The performance of the supercapacitors improved, and we can do X and Y with it. And that's a project that's right back on the drawing, being worked on right as we speak now. So it can vary. It can be quite short. It can also be excruciatingly long. And as I just repeat the comment I made before, when dealing with other parties, and I'm sure the other CEOs, anyone who's been in this situation will understand, when you're dealing with other parties, you can't control the timetable always. There's other parties that have to come along and agree to that, just steps through the processes. So we can give best indications of what we think is a time frame to expect an announcement, but we often if it's not inside our control, we live at someone else's mercy there.
Thank you, Anthony.